Okay, so we built an egg drop contraption, right? And the egg drop contraption had lots of things that involve forces, and we didn't really do a lot with it, but we're going to kind of refer back to the egg drop contraption a lot throughout the course of this unit. So the very, very first thing that we're going to talk about is we're going to talk about how the forces apply to everything, and then we're going to draw some force diagrams for your homework today. And so it's not really difficult, but there's a few things.
The only note sheet we're getting
Today. There will be more. I don't know. Okay, now we need to define what a force is. You might want to write this down at some point or another. A force is a push or pull on an object by another object. Okay, the object of the force diagram is always drawn as a dot so that you don't have to draw things like cats and skateboards and mice and things like that. So really what you're going to be doing is just drawing a dot. The forces on that object are drawn as arrows in the direction of the force. So those are some things that you just kind of need to keep track of for the time being. And then now we're going to go through the, let's see, 1, 2, 3, 4, 5, 6, 7, 6 different types of forces. So the first type of force that you're going to be responsible for understanding is the gravity force. The force of gravity is the pulling force on an object by the earth. So the other way that we define gravity is the attractive force between a larger object and a smaller object. Did we talk about this already? About how sometimes when you're walking down the street, or maybe at the Summerfest, or maybe at the state fair, and you see a couple that is together and they're holding hands, and one of them is a giant human being and the other one is a really, really skinny, petite human being. And I've decided that the giant human being has a gravitational force that pulls the tiny human being to them. And you can test it by running in between them and breaking their hands apart, and they'll come back together and hold hands again, just like gravity on the earth works on you. So like when you try to jump away from the earth, you jump up and the earth pulls you back down. Do you buy that? Okay. That must be the force of love then. That's another force. That's something else altogether different. But anyway, the force of gravity is the pulling force on an object by the earth. And so generally, when we see the force of gravity, it's pulling an object down, and we represent that as Fg, the gravitational force. Okay. Now, on the dot to the right of your diagram, I'm going to take and draw this guy down going like this here, and I'm going to put Fg. And we always label our forces. We have to label them. If we don't label them, people are going to get confused and not know what's going on. So when you're drawing your diagram, you're going to always include a gravitational force, unless, of course, you are in space. But on Earth, you will always include a gravitational force. Any questions about gravity and force? Responsible for understanding is the normal force. And the normal force is the supporting force on an object by another object that is touching it. So we generally will draw the normal force as a opposite to, as an opposite to the gravitational force. So if the gravitational force goes down like this, which is true, and I'm going to draw it over here on our dot for our force diagram. I understand that, but like you're going to be continuing to add to it. Okay. And then the normal force is the opposite of that force. And so it goes like this, and we call that the Fn. Okay. So generally speaking, they should be about the same length because usually they cancel each other out. So if the gravitational force is pulling you down, the normal force, that is the force of the that's the force of the earth pushing away from you, and you're pushing away from the earth. So that kind of cancel each other out. So as a result of that, you don't get pulled into the earth and like quicksand. I don't know, when you were a little kid, like quicksand was a real scary thing when I was a kid. Like I thought everywhere that you went in the jungle, there was always quicksand and you were going to die. But like apparently it's not a thing anymore. Like nobody's worried about quicksand.
Can you go back this way?
How did you miss that?
I don't know. write it down.
Oh, you should watch the video. The next force is the force of tension. Okay. Now this one, you're probably not going to have a space to draw because this one is like different than the other couple. But the tension force, so you might want to maybe draw a little guy like this off to the side for this guy. So the tension force is the pulling of a force on an object by a string or a rope. So in this case here, we have a stop and go light, which is clearly on the go situation. And as a result of it being on the go situation, what we're going to end up with is we're going to end up with a stoplight hanging in the middle of the street, and it has these two strings that are attached to it, and these two strings are being pulled off in opposite directions, and they're essentially canceling each other out. So we call that the force of tension, or the tension force. But again, we have that force of gravity that's going to pull everything down. So in this case, the gravitational force is being counteracted by both of the forces of tension. So in reality, the forces of tension are keeping the stoplight from hitting the ground. And there's two forces of tension in this case. Is that okay so far? Moving on. Any questions? Did you get that? Waiting. You might want to draw this off to the side so you can see it once. So you drew it. Excellent. Okay. Which again, you might want to draw this one off to the side. This is called the spring force, and the spring force is the force that we use when we discuss things like how springs are being affected by the different forces. So this is the force of an object by a stretched or a compressed spring. So in this case, the force of the spring force is going to be going up. We call that Fs, but we have to remember that it's always going to be in after effect to gravity. So we have Fg on the bottom. So the spring force is working against the force of gravity. It's different than the normal force though. And the reason why it's different than the normal force is the normal force is the force applied by when two objects are touching. And because the spring force, the object is not touching anything other than the spring, it's not the normal force that we have to worry about then. So I'll pause that. The last force we're going to talk about, well, not the last force, but one of the last forces we're going to talk about is the force of friction. And the force of friction is the force on an object by another object that is touching it, which always opposes or works against the movement of said object. So in this case, the force of friction will most likely be, moving, we'll make it that color. The force of friction will be moving away from, oops, that's not what I wanted. Where'd it go? There it is. So the force of friction is going to be moving in opposite of the force that's being applied, which we're going to talk about in a minute. So this is the force of friction. Okay. Now, how that applies to everything else we've talked about, well, here is the force of gravity, or gravitational force. Here is the normal force. And here is the force of friction. We're getting there, sir. Okay. Now, so we have the force of friction, the normal force, the gravitational force. Not 100% sure what's going on here with this letter. Just going to kind of try to clean that up a little bit. There we go. All right. Any questions about the force of friction? This one you can definitely add to the diagram at the bottom. May I move on now? Which is the next guy that we need to talk about, is the force on an object that moves or attempts to move an object. So the applied force in our case is going to be, let's see, I should find a new color for that. Let's see. There, that'll work. Okay. So the applied force is going to be the force that is going to be trying to move the object. So this is going to be force applied. Okay. That's going to be the force that's trying to move an object. And if the object moves, that force has to be greater than the force of friction and the gravitational force and the normal force. So if we're going to put this all together, we have our normal force, we have our force of gravity. We have our normal force. We have our force of friction. And we now have our applied force. Okay? And so at this point, what I hope that you can see is that when I drew my arrows, my applied force was bigger than my force of friction. If my applied force is bigger than my force of friction, what do you think is going to happen to the object? Is it going to stay stationary or is it going to move? It's going to move. Okay, so if the force of friction is greater than the applied force, will the object move? Will the object move backwards? No, it won't move backwards. That's silly talk, right? So like if this is my chair, okay, the gravitational force is pulling it down, the normal force is pushing it up. Right, and so it's staying right there. If it hasn't started moving yet, but if I give it some force, I'm pushing just a little bit. Currently, I am not applying enough force to move the chair, so the force of friction is greater than the force that I'm applying. Okay, but if I apply more force, I am now overcoming the force of friction, and I am now able to move the chair. And the more force that I apply, I didn't break science. The more force I apply, the faster the object will move. So that is really all that we need to talk about today. Questions? Your homework then is literally the back side of this. It's this guy right here. You are going to be drawing force diagrams for all of these scenarios. There's a book on a table, a light bulb hanging from a string, a little kid pushing a ridiculously large kid in one of those little Tykes cars, one of those bungee cord things that seems like a stupid idea to pay $75 to do, a kitty going up a ramp, whatever, and a human throwing a piece of pizza in the air, and then a car at 0 versus a car moving to the left, and then me punching a punching bag. What you're not seeing is the punching bag rips apart and threads and just shreds everywhere. I wear a skull cap when I box because